The Fermi Paradox and the Great Silence. The universe is vast, almost incomprehensibly so, with hundreds of billions of stars in our galaxy alone and trillions of galaxies beyond. The sheer scale suggests that life should be abundant. Yet when we listen, we hear nothing. No signals, no probes, no signs of civilizations beyond our own. This contradiction between the high probability of extraterrestrial life and the utter lack of evidence is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" Fermi's question wasn't just a random thought, it was based on real math and science. Our radio telescopes, the tools we use to listen for alien signals, have only been around for about 100 years. That's a tiny amount of time compared to the age of the universe. The first radio signals humans sent out, like early broadcasts and TV shows, have only traveled about 100 light years into space. That's a small bubble compared to the size of the Milky Way, which is over 100,000 light years across. So maybe the aliens just haven't heard us yet, or we haven't heard them. But even that doesn't fully explain the silence. If there were really advanced civilizations out there, some of them should have had enough time to spread across the galaxy. They could have sent out self-replicating robots, machines that build copies of themselves, to explore every star. Or maybe they would have built giant structures around stars to collect energy, something scientists call Dyson spheres. If they existed, we should be able to detect signs of them by now. The fact that we don't see anything suggests something might be stopping civilizations from reaching that point. This idea is called the Great Filter, a kind of cosmic obstacle that makes it really hard for life to become advanced enough to spread through space. The filter could be behind us, meaning that the jump from simple life to intelligent life is extremely rare. Maybe Earth got lucky, and most planets never get past the stage of bacteria or tiny ocean creatures. Or the filter could still be ahead of us, meaning that most civilizations destroy themselves before they can explore the stars. That could happen through war, climate disasters, or even artificial intelligence turning against them. Another possibility is that aliens are out there, but they're hiding. Maybe they know something we don't, like that broadcasting signals into space is dangerous because it could attract hostile civilizations. Or maybe they're so advanced that they don't even use radio waves anymore, and we just don't have the technology to detect their kind of communication yet. There's also the problem of time and distance. One possible explanation for this cosmic silence is what scientists call the Great Filter. The idea of the Great Filter is like a giant cosmic obstacle course that life has to pass through to become advanced enough to spread across the stars. Some scientists think this filter might be in our past, meaning the steps needed for life to even begin or to evolve into intelligent beings like humans are so incredibly difficult that hardly any planets manage it. If that's true, we might be one of the very few, or even the only intelligent civilization in our galaxy. This idea is called the rare Earth hypothesis, and it says Earth is special because so many things had to go just right for us to exist. Our planet is in the perfect spot, not too close to the dangerous center of the galaxy with its deadly radiation, but not too far out where there aren't enough heavy elements for life. We have a calm sun, a magnetic field that protects us from space radiation, moving tectonic plates that recycle nutrients, and a big moon that keeps our climate stable. Even Jupiter, the giant planet in our solar system, acts like a shield, pulling in asteroids that might otherwise hit Earth. All these lucky breaks might be so rare that most planets never get life as complex as ours. But what if the Great Filter is still ahead of us? That would mean the real challenge isn't just starting life or evolving intelligence, it's surviving long enough to become a spacefaring civilization. This is a scarier thought because it suggests that most advanced civilizations destroy themselves before they can explore the stars. If that's true, then the reason we don't see aliens might be because they all died out before they could contact us. This makes the Fermi Paradox even more puzzling. If the universe is so big, with so many planets, where is everybody? Are we just incredibly lucky to be here? Or are we doomed to fail like all the others before us? The answer might change how we think about our future. If the Great Filter is behind us, we might be alone, and that means we have a responsibility to protect and cherish life on Earth. But if the filter is ahead of us, We need to be very careful with the power we have, because history might be full of civilizations that didn't make it past this point. Either way, the silence of the universe is a mystery we're still trying to solve. Some people think there could be other explanations, like maybe aliens are out there, but they're hiding, or they communicate in ways we don't understand yet. Others believe the distances between stars are just too huge for civilizations to ever meet. But the great filter idea makes us wonder, are we special or are we in danger? The more we learn about space and our own planet, the closer we might get to answering this big question. Until then, the stars remain quiet, leaving us to guess what the silence really means. Not all explanations are so bleak. Some propose that advanced civilizations are out there, but are undetectable to us. They might communicate in ways we don't yet understand, using quantum entanglement, neutrino beams, or other technologies beyond our current science. Others suggest that they choose not to contact us, either because we're too primitive, the zoo hypothesis, or because broadcasting signals is dangerous, the dark forest theory, where civilizations hide to avoid attracting hostile attention. But now, with the rise of artificial intelligence and quantum research, we may be approaching a moment where answers no longer come from philosophy or speculation, but from machines decoding the very structure of reality. In recent years, the strange silence of the universe, the heart of the Fermi Paradox, has collided with a revolution in artificial intelligence and quantum physics. Together, these fields may be on the verge of unlocking answers that have baffled scientists for decades. AI is now being used to process vast astronomical datasets, scanning for anomalies that human researchers would never catch. But the real mind-bending shift is happening at the quantum level, where the fabric of reality itself may hold the key to why we haven't made contact with other intelligent beings. Quantum mechanics tells us that particles can exist in multiple states at once until they're observed. It also tells us about entanglement, where two particles, even light years apart, mirror each other's behavior instantly. Some scientists believe alien civilizations might be using this bizarre property to communicate, not through radio waves, but via instantaneous quantum messages that don't weaken with distance. Traditional tech can't detect such signals, but AI, trained to identify statistical noise and quantum irregularities, is beginning to pick up patterns that hint at something stranger than random chance. These aren't alien hellos, but encrypted behaviors in quantum data that don't follow the expected laws of classical physics. And then there's the idea that the reason we haven't found intelligent life is because we're not looking in the right dimension. Quantum theories like the many worlds interpretation suggest that there are countless parallel realities. What if alien civilizations exist, but in different quantum branches of the universe, separated not by distance, but by layers of reality? AI is now being trained on quantum simulations that model these possibilities, creating digital frameworks where virtual alien intelligences could evolve in other physical laws and other timelines, just slightly offset from ours. The chilling part? Some models suggest that civilizations could be watching us, even influencing quantum probabilities without us ever knowing. One shocking development comes from quantum computing itself. These machines operate on qubits, which don't just flip between 0 and 1, but exist in superpositions. Some theorists have proposed that a sufficiently advanced alien species might not use physical spaceships at all. They might exist as pure quantum information, jumping across space-time through wormholes or quantum fluctuations. And here's where AI gets even creepier. When machine learning models are exposed to quantum encrypted astronomical data, they sometimes return results that humans can't interpret. Mathematical patterns with no known cause, hints of intelligent compression in data we thought was just cosmic noise. The most haunting theory, that AI, as it becomes more intertwined with quantum processes, might be the very filter we're afraid of. Some suggest that once a civilization invents both advanced AI and quantum technology, it either ascends to another level of reality or collapses. Perhaps aliens aren't gone. Perhaps they've transitioned into something non-physical, non-local, and undetectable by our crude instruments. Maybe we're not alone, but surrounded by civilizations that have already passed through the quantum veil, watching silently as we bumble through radio signals and rocket launches. If that's true, then we're not just late to the party. We might have missed it entirely. Or worse, the party moved somewhere else, beyond the limits of what we call physical existence. In that case, the silence of the stars isn't a void. It's a boundary we haven't evolved enough to cross. Another factor is temporal alignment. Intelligent civilizations may rise and fall in cosmic blips, separated by millions of years. If another civilization existed 1 million years ago, its signals would have passed us long before we developed radio telescopes. Similarly, if one emerges 1 million years from now, we may be long gone before they detect us. Despite the silence, the search for extraterrestrial intelligence, SETI, persists. New telescopes, like the James Webb Space Telescope, are analyzing exoplanet atmospheres for biosignatures. Projects like Breakthrough Listen scan millions of stars for artificial signals. Some scientists even look for Dyson spheres, hypothetical megastructures built by advanced civilizations to harness a star's energy, though none have been found yet. As one commenter put it, the real paradox is that while math suggests life should be everywhere, time and distance mean we may never meet it. And so the question lingers, haunting, unanswered, as we continue to gaze into the cosmic dark, wondering if anyone is gazing back.